The LEGO Group has factories across the world. But how do you produce hundreds of different types of bricks with such precision and in a wealth of colors every single day? High-tech injection molding machines produce LEGO elements 24 hours a day, 7 days a week. First, the raw granulate is mixed with the dye. Bricks are currently produced in over 50 different colors. The colored granulate is then led into the molding machine. Within no time, the granulate is heated to between 230 and 310 degrees Celsius. The plastic melts into a texture much like toothpaste. With great force, the paste is then fed into the mold. Great forces must be controlled during this process. The pressure can reach 29,000 psi. In comparison, a car's tire pressure is 29 to 43 psi. In the mold, the material is cooled in a matter of seconds, and out comes a newborn LEGO brick as we know it.
The exercise that will be solved in this video is about a 2 to the k experiment, run with 4 factors. The response variables measured are the molecular weight and the viscosity of the final LEGO brick. The factors tested were the temperature, the catalyst concentration, time, and pressure in the injection machine. After running some tests, the following data was obtained. Finally, the instructions for the exercise are to run a Daniels test in order to identify which factors affect the response variable. Then, an analysis of variance has to be done to confirm the Daniels test results and to verify there is no sign of curvature in the system. The next step is to get a regression equation to predict the response variable as a function of the important variables. Finally, the residuals have to be analyzed to find, if there is any, the factors that affect dispersion. The instructions are to be completed twice, the first time for molecular weight and then for viscosity. The first step is to do the Yates algorithm using the molecular weight data. To do the Yates algorithm, you have to identify the data by couples, and then the procedure is to fill the column next to it with the sum of each pair, followed by the subtraction of the second number minus the first one. On the image shown, the data pairs were identified using green and pink colors. The blue numbers were obtained from the sum of each couple, and the purple numbers from the subtraction process. The process continues until you complete as many columns as factors you have. In this case, 4 columns were needed. In the final column, the first number is the sum of all the data, and all the other numbers are known as contrast. Once you have the contrast, the next step is to calculate the location effects and the sum of squares of each factor, using the formulas shown. To obtain a Daniels test, the location effects of the factors must be sorted from the smallest value to the biggest one. After that, a probability must be given to every effect. Once you have all the necessary, the data must be plotted. The points that fall away from the tendency line of the majority correspond to those factors that affect the location of the response variable. In this exercise, factors A and C and the AB interaction are suspected to affect the molecular weight of the LEGO brick. For the second part of the exercise, an ANOVA table has to be done. As a result of this analysis, you will be able to confirm if the Daniels test results are correct or not. Also, the problem asks us to check for curvature. This is analyzed with a special factor called the SS pure quadratic. In this special case, the sum of squares of the error has its own formula. For this exercise, we confirm that the factor A, C, and the AB interaction affect the values of the response variable. We also get that as the F value of the SSPQ is smaller than the F table value, there is no evidence enough to say that there is a curvature. in the system. The next thing to do is to get a regression equation model for the system. This is done by the addition of the average of the data and half of the effect of every significant element. The average can be obtained by the division of the first number of the last column of the Yates algorithm over the number of data, and the effect of all the elements have already been calculated. Once you have the regression equation, it is possible to obtain the residuals. You calculate first the y expected values for every combination of the factors, and then get the residuals. The residuals can be analyzed with an F* test for dispersion effects. A special table must be constructed. The factor signs are copied as they come from the data table, and the interaction signs are simply the multiplication of the factors involved. Once you get all the signs, you add the residuals column at the end. The next step is to calculate the variance in the residuals for each element. Two variances have to be calculated for every element. One for when the element is in its high value, and other for when it is in its low value. After the variances are calculated, the F* value for each element can be obtained. Finally, similarly to the Daniel's test, the F* values must be sorted and assigned with a probability. Then it must be plotted, and the same criteria as the Daniel's test can be used. In this case, the obtained chart is not really clear, but the triple interactions ABC and ACD seem to be the ones who caused the problem. The only thing left to complete the exercise is to do everything again but using the viscosity results. We start again with the data table and the Yates algorithm to obtain the total sum and the contrasts. Once we have the contrast, we calculate the location effects and sum of squares of every element. Then we proceed to do the Daniel's test. In this case, we obtained that only factors A and B affect the value of the response variable. We run an analysis of variance to verify the Daniel's test results and to check for curvature in the system. This time we also obtain that there is no curvature. The next thing is to obtain the regression equation with the effects of factor A and B only. Once we have the regression equation, the residuals can be obtained. The F* test is the same as the one we did before, using the same special table. This time, the chart obtained is more clear and shows that the factor A affects the variance of the response variable. A residuals versus levels for factor A can be done to identify which level generates greater variance. This information can be useful to make a decision later. And that is how you solve this exercise. With the information obtained, you could make better decisions in order to obtain the results you want from the process you studied.